Okay, so get this, Google, they were trying to like tackle AI bias,
Yeah.
with their new image generator, Gemini. But it kind of backfired.
Oh, yeah.
Yeah, it ended up creating a whole bunch of controversy.
Oh, wow.
Great power comes great responsibility. And AI, that's definitely a powerful tool.
Oh, absolutely. And we've seen what can happen when it's not used responsibly, like with Gemini.
Yeah, exactly.
It's a good reminder that we need to be proactive about this, not just reacting after something goes wrong.
So if we can't totally get rid of bias in AI, what can we do? I mean, how can we at least make it better?
Well, for starters, we need more diverse teams working on AI development. Having people from different backgrounds with different perspectives and lived experiences can help identify and address potential blind spots in the design and training of these systems.
Analyzing Gemini's diversity failures and Notebook LM's training data impacts on bias, Google's Gemini AI, designed to promote diversity in generated content, faced backlash when its efforts resulted in culturally insensitive and historically inaccurate depictions. While the intention was to correct historical exclusions, overemphasis on diversity led to errors, such as portraying black individuals in Nazi uniforms or a black woman in papal attire, which did not reflect the historical realities. These failures point to the core issue with forced diversity. While diversity in training data is necessary, it must be implemented thoughtfully. Simply adding diversity without context can exacerbate bias. As seen in Gemini's results, the AI cannot self-correct, which raises concerns about the responsibility of developers to ensure accuracy and avoid misrepresentation. Training data and bias in AI models, including Google's Gemini and Notebook LM, are heavily influenced by their training data. If the data is skewed, the model will reflect those biases, sometimes in unintended ways. Notebook LM, while improving upon Gemini's approach by incorporating more contextual understanding, still faces challenges in eliminating bias. The effectiveness of adding diversity in training data depends on how it's integrated, as well as the model's ability to handle complex cultural and historical contexts. The impact of forced diversity can sometimes make the problem worse if not handled properly. In the case of Gemini, the model was trained with a focus on diverse representation, but this came at the expense of historical accuracy. The result was imagery that felt disconnected from reality. True fairness in AI requires balancing diversity with historical and cultural sensitivity. This remains a key challenge for developers. Developer responsibility in addressing AI bias. AI systems rely on developer input to address and correct biases that can emerge during training. Without the capacity to self-correct, these systems require consistent oversight. In cases where diversity is integrated without sufficient context, unintended biases may arise, as seen with Gemini. This highlights the importance of developers creating balanced training data that reflects cultural and historical accuracy, along with ongoing refinement based on user feedback and evolving societal standards. Conclusion: while increasing diversity in training data is important, forced diversity without contextual understanding can lead to negative outcomes. AI developers must strive for a balance, ensuring that models like Notebook LM can represent a wide range of perspectives while maintaining accuracy and cultural sensitivity. This requires continuous oversight and refinement, along with a commitment to avoiding biases, whether in favor of diversity or otherwise.